Objective 10. Use scientific notation. A number is written in scientific notation if it is in the form of n times 10 to the k, where n can only have one non-zero digit in front of the decimal point and k must be some integer. We want to determine which numbers are written in scientific notation. If we take a look at the first example, 3.4 times 10 to the negative 2, we have the decimal point, and again, that's what the definition is saying here. The definition says that n can only have one non-zero digit in front of the decimal point. So if we take a look at this 3, we have one decimal point in front of that. So we have 3.4 times 10 to the negative 2. So yes, this is in scientific notation. If we take a look at B, we have a decimal point in between 5 and 8. So this is considered scientific notation. So negative 5.87 times 10 to the 5th. In part C, the decimal is after the 3 and it should be in between the 1 and 3. So therefore, this is not considered scientific notation. Same thing with part D. That decimal has to be in between the 3 and 4, and since it's not, this is also not considered in scientific notation. Now the procedure to convert from scientific notation to standard decimal form, if k is positive, move the decimal point k places to the right. If k is negative, then you move the decimal point k places to the left. So we're going to write the number in standard decimal form. Here we have 8.47 times 10 to the negative 7. So that means that we need to move this decimal point to the left 7 times. So starting at 8.47, we're going to move over 1, 2, 3, 4, 5, 6, 7, and then put the 0 in front of the decimal point. So we have 0.000000847. For part B, we have 3.5 times 10 to the negative 4. So we're going to write down our number 3.5, and it says negative, so we're going to move over 4 places to the left. So we're going to move over 1, 2, 3, and then 4, and there's your decimal point. So we get 0.00035. Next, we have negative 4.71 times 10 to the negative 5th. So we're going to write down 4.71, and since it's negative 5, we're going to move to the left 5 places. So we move over 1, 2, 3, 4, 5, and have our decimal point. So it becomes negative 0.0000471. Next, we have negative 3.2 times 10 to the 3rd. So we write the number negative 3.2, since it's positive 3, we're moving the decimal place to the right 3 times. So we're going to move over 1, 2, 3, and that gives us negative 3,200 or negative 3,200. The next example, we're going to write the number in scientific notation. So in this case here, we have negative 465 million. So in order for us to rewrite this in scientific notation, what we do is we're going to write 10 times 10 to the 0 power, because if we recall, 10 to the 0 power actually equals 1. So what I mean by that is, let me write this out. So if we write negative 465 million, we write that times 1, okay? And that means the same thing as 10 to the 0, because you remember 10 to the 0 is going to give you 1. And then what we want to do is, at that decimal point here, we're going to move over 1, 2, 3, 4, 5, 6, 7, and then 8. So that means we're moving it 8 times to make that number look smaller. So what we end up getting is negative 4.65 times 10 to the... Okay, so now looking at part B, we have our number that's there's 8 zeros, 3, 5, and we would write that times 1. Just like we did in the previous example. Okay, and then we can rewrite this as 0.1234567 and remember that 1 is the same thing as 10 to the 0 power. So now what we want to do is then we want to make sure that we finish the decimal in between a 3 and a 5. So from this decimal point here, we're going to move over 1, 2, 3, 4, 5, 6, 7, 8, 9. But see, we're making this number, it's smaller, and what we're doing is putting this in scientific notation. So since we're moving this to the right, that's going to become minus 9. So then our result ends up being 3.5 times 10 to the negative 9. So likewise, if we look at part C, okay, the decimal is over here on the left-hand side. We're multiplying it by 10 to the 0. So we're going to move it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to add 10 because we're moving this in this direction. So 3.7 times 10 to the 10th power. And then over here, we have negative 0. And here's our decimal point. We want to make sure it's in between the 4 and the 8. So we're going to move this, remember, it's times 10 to the 0 power. And we're moving it in the right towards this direction. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to subtract 9 from that 0. So we end up getting negative 4.88 times 10 to the negative 9. Okay, so let's talk about this in terms of our calculator. So we're going to see when you're using a calculator, especially in statistics, okay, this can also be represented by negative 4.65 e and then 8. Okay, this is the same thing as 3.5 e to the negative 9. This is the same thing as 3.7 e 10. And this is negative 4.88 e to the negative 9. Okay, so let me highlight these so we can distinguish the difference between these two. So this is the calculator version of how this is looked at when you see this display on there. Okay, and let's just go ahead and take a look at that. So in our calculator, right, we have, let's see here, we have negative 465 million. Okay, so that's our number. That's the number that we have here. Now, when we write it in scientific notation in terms of a power of 10, this is what we have. But on a calculator, it's written differently. They don't have times 10 to the 8th. They use this e to represent times 10. So the e in a calculator is the same thing as times 10, and whatever the power is what is written right after the number e, or the letter e, excuse me. So let's go ahead and plug this in. So if I have negative 4.65, and you see this e here, I'm going to go ahead and hit second and then e, and then I'm going to put in the value of 8. Gives me the exact same number. So that's how you're reading the scientific notation number on a calculator. Let's take a look at 3.5 times 10 to the negative 9. So we have 0.12345678335. Right? That is the number, and you can see here what we get is 3.5 e to the negative 9, which is the same thing as 3.5 times 10 to the negative 9. Let's take a look at this next one, 37 billion. So 37, so you have 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so let's see what it gives you. It gives you 3.7 e to the 10, which is the same thing as 3.7 times 10 to the 10th power. And then likewise, we have this following, so we have negative 0.1234 5678 and then if we hit enter, then you can see the scientific notation is in negative 4.88 e to the negative 9, which is the same thing as negative 4.88 times 10 to the negative 9.